Hello students, and welcome again to my channel. My name is Mr. Meshak Ngige and welcome to eMaths with Mr. Meshak Ngige. Kindly, have you subscribed? Have you commented? Have you shared? Kindly, if you have not done so, share, comment and also subscribe to my channel and let it be known to as many people as possible as we share the knowledge of mathematics. Now, today we're going to be looking at another topic that is on Fourier series, and particularly we're going to be focusing on questions and come up with their answers. And these are a very good question that carries some good marks. So if you know how to do it, then this is good for you. Now, today we're going to be checking at a question where you've been given a function that is periodic. So you're given a question that given a periodic function, the function is represented by ft. So our variable is t, okay? This is a function of time. So then we have pi minus t, then you have the function. This function runs from negative pi to 0, then the second one runs from 0 to pi. So you're supposed to sketch the graph for 3 periods: 2, determine the Fourier series, and 3, by letting t equals to 0, show that pi squared over 8 equals to summation from n equals to 1 up to infinity of 1 over 2n minus 1 squared. So solution. So first of all, we shall just start by sketching. Then before we determine the Fourier series, we have some few things, NBs, that we have to know about. Now, so sketching, how do you sketch? Remember, these are the limits, right, together. So these are the limits of your particular function. So we have from negative pi to 0, 0 to pi, right, together. Now, so for us, we have, these are the limits of t, and we have to get the function of ft. So we shall be replacing our limits in where we have t. So negative pi and 0 will fall in this first function. Then we have the second, which will fall in the second function. So we start. We have to get our points, our point of sketching. So when t equals 2, our first limit is negative pi. So you replace negative pi here. Your ft will be negative pi minus pi. Are you together? So negative pi minus, this one will give you a positive. So this one gives you negative pi plus pi. This one gives you what? It will be 0. You come to the second limit. It is 0. So replace with 0. So negative pi. So when t is 0, your ft will be negative pi minus 0, which just gives you negative pi. Then you come again when t is 0. Now we come to the second function. So this limit applies to this. So you'll have your ft. So remember, these are two functions, this one and this one, but all of them are just a summation of the whole function together, but they have just been split into two, right, together. So the limit applies to each particular function. So 0, you replace it here. Again, we'll have negative pi plus 0. Again, it gives us negative pi. Then you go to the last limit, which is t equals to pi together. So replace pi here. So you'll have ft negative pi plus. So your t is pi. So therefore, this one gives us what? It gives us 0. Now remember, these points here are what you're going to be sketching. This one will represent your x-axis where you have your t. This one will represent the function ft. Are we together? So now, just a sketch. Remember, these are sketch. We can see our values of ft is 0, negative pi, 0. So our value basically will lie at the lower side. So we are saying this one will be your t, this one will be your ft. Are we together? Your t and your ft. Then we sketch. So we know our limits will run from negative pi. We have 0 and we have what? We have pi. Negative pi, 0, 0 and pi. So that is the maximum. Then we know our limits go from 0 of ft, which is on the y-axis. It is 0, negative pi and 0. So we know the maximum value it can go on this side is what? Negative of pi. Are we together? Yes. So now let's get the points. Negative pi, 0. So when your t is negative pi, your value of y is 0, your ft. So it will be this point here. Are you together? We come to the second. When t is 0, your value of ft is negative pi. So 0, negative pi. I believe we know how to sketch points in the x and y axis, okay? Then again, when it is t, negative pi, so when t is 0, negative pi again, 0, negative pi, so it will fall on the same point. Then you have pi 0. When it is pi, your value of y is 0. So therefore, you'll have then join the 3 points. So you'll have a value like that. So I've been told to sketch how many periods? 3 periods. So you can sketch one on the right, one on the left, the same appearing the same way. So you have that. You have that. So this one will be negative 2 pi. This one is negative 3 pi. This one is pi. You have 2 pi. Then you have 3 pi. So therefore your function sketched in 3 periods, then it will be represented by that, and that is number 1. So we take that. Now after sketching, the sketching of graphs in Fourier series is very important because it can save you a lot, because it enables you to understand, is the function odd, is the function even, or is it neither odd or even. Are we together? Now by sketching this, we can see, if you know how to identify functions which are even, which are odd. Let me just explain it in a very simple term, why this function, this particular function is an even function. Is an even function. This one is an even function. Now what is an even function in terms of, if you can just check it from the curve, from the drawing. How do you know if a function is even? It is very simple. Functions that are even are symmetrical along the y-axis. Are we together? So if I have a line here, so let me have a good illustration here. So if I have a line, then I draw, then I have this is the x, this is the x and y, so I can just have those two. So if you have, let me check just any other drawing or a sketch. So if this is the y-axis, this is the y-axis, this one is the x-axis. So we say even functions are symmetrical along the y-axis. What does that mean? This one simply means if I flip, if this is my y-axis and it is at the center, if I flip this, if I flip this line upon this line will lie on this line directly. Right together. This line will lie on this line because it is symmetrical along this line here, along the line. So if I were to flip it, then this line here will lie on this particular line directly. Then this, any function that will be symmetrical along this y-axis, then we say that function is even function. So we can see our function here, that this function here, this part here of the function, because remember these ones are just extensions, so you're working from this point to this point. So if this is my y-axis, if I were to flip this part here, this line, this particular line will lie on this particular line. Right together. So this part and this part, you can see it basically forms two sides of a triangle that are just the same, whereby if I flip, if I close this triangle here, the line will lie on each other. Now that is how you know a function is an even function. Are we together? Now this one, how does this help you when it comes to calculation of Fourier series? Now calculation of Fourier series involves finding the constant terms a0, an and bn. Now when we are working with an even function, we know that an even function does not contain the sign series. Are you together? It only has the cosine series. And which values have cosine series? It's only an. Are we together? And now when you talk about even function, then we say there is always a possibility of having a naught. So you shall be finding two things here, not the whole lot of a Fourier series. You shall be finding a naught and an alone, only those two. Bn value will always be a 0, because you are working in an even series. And remember, a sine function is an odd function, and a cosine function is an even function. So when we say we don't have a sine function, we don't have sine functions or sine series, we are just saying we don't have the odd part of that particular series. Right, together. So we have that. So we have our value. So that is the first thing. So sketching here enables you to understand if a function is even or if a function is odd. Now, let's now go to a few aspects that you need to remember, to note, that we shall be using here. So you can have this one as NBs. Let me have it here. NB. You need to know some few things. That's okay. Sine of n pi will be replaced by 0. Okay. Then cosine of n pi will be represented by -1, then power n, and 2n minus 1 will be used to represent an odd value. And this one is true. Why? Because if I take 2, I take any value of n, okay, 1, for example, 1 times 2, 2, 2 minus 1 is 1, that is an odd number. I take 3, 3 times 2, 6, 6 minus 1, that gives me 5, 5 is an odd number. So 2n minus 1 shall be used to represent an odd number. So you can already see something here. Right, together. This one is an odd, this one is an odd number representation. Okay, so we have that. Now, let's come to now the formulas that are being used in calculating A0 and AN. Remember, our expansion, our Fourier series of FT will be given by, so you can note this one somewhere, plus. Now I can give it in terms of AN, so we shall have AN, then cos n pi t over L. Then let me just put it in terms of a summation, okay? Let me just put it in terms of summation. So plus n equals to 1 up to infinity. That means when n is 1 here, then my value changes. When n is 2, my value changes. When n is 3, remember this one is AN. AN means it depends on the value of n by the end of the day. So my Fourier series here will be given by this, because I'm only interested with A0 and AN. Now remember, this formula can be used either when you are using limits in terms of pi or even numbers. Are we together? This one is a general representation for this. Now, so we need to get two things. We need to get A0 and we need to get AN. How do you get A0? N0 will be given by 2 over L from 0 to L ft, because we know that our function is what? Our function is even. Very important formula. Then I'll explain something here. AN will be given by 2 over L from 0 to L ft, then cosine of n pi t over L, then dt. So this one is cosine, alright? This one is cos. So we have 2 over L ft. So here you're only integrating the function only. Alright, together from 0 to L. Then here we're integrating the function together with the cosine. So it is ft, then cos of n pi t over L, then dt. Now, let's see. Why do we use these particular formulas? Remember, when you're working with the general Fourier series, you shall take limits from the starting point to the ending point. So what I'm saying is, you'll take the integral from negative pi to pi of this function, then from 0 to pi, then you add the two of them together. But now when a function is even, we say, let's just work one side of the function. Okay, let's just work one side of the function, then we multiply it by 2, because we have two sides. Assume this one is just a triangle. Are we together? If I was to get the area of this part, the area of this triangle will be the same as the area of this triangle here. Let me take it in terms of triangles. The area of this triangle and this triangle are the same. So instead of working the whole triangle from the limits in the negatives, let me just work with the limits on the positive side. Then whatever I get on this side, I multiply it by what? By 2. Right together. Therefore, our value 2. Right together. So it is 2. Then over L from 0 to L, then FT. The same here. Now, our 0 to L basically means we are working on values on the positive side. We're interested from 0 point going forward. So 0 going forward. Right together. And you can already see where your L, what your L is. Your L will be what? Will be pi, because our function starts here and it ends here. Alright? But now, how do you get your L? How do you get this value L? No, with just no assumption per se. How do you get it? How do you calculate it? It is a very simple thing to do. Now, in some functions, you shall be told the period after which this function repeats itself. Are you together? We have already been told it is periodic. But after how long does it repeat itself? When we say periodic, it means it is repeating itself again. After a certain period, it repeats itself again. So how do you know after how long it repeats itself? So it is very simple. What you just do, you take where it ends, where the period ends, the first one period ends, and where it started. So if you want to know the exact period, then for us to get the total period, I'm saying this because sometimes you're given, sometimes you're not given in terms. So sometimes you might find a value written such as this, t plus 2 pi. So let's calculate it first, then I tell you what this means. So take the end, subtract the beginning. So you have pi minus, our beginning is what? Negative pi. So the total period of this function, for it to take one period, then it will be 2 pi. Then it repeats itself again. Right together? Yes. And you can see that from this point to this point, from this point to this point. So you can take this minus this. So what is 3 pi minus pi? 2 pi. If you take this point minus this point, the same thing. Right together. So it is 2 pi. So 2 pi represents your total period. And now I'm saying, if this part is written at the bottom of this function, then whatever is here represents the period t. After the period at which these were the function repeat itself. But if it is not given, you can calculate it by taking where it is starting, where it ends, subtract where it started. So how do you get your value of L? So we shall compare our L with our period t. We always compare 2L with our period t. So therefore in this case we have 2L, our period is what? 2 pi. So divide by 2, divide by 2. So our L is equals to what? Our L will be given by pi. By calculation, by just working it from the graph that you've been given there, from the functions, okay? So your L will be pi, but again you can just see what it was, from 0 to pi. So that is just basically your L. So it is important to note what your L is. So now we have everything we need. We have 2, we have L, 0 to L, ft, ft. Now, since your function starts from 0 to L, and your L is pi, 0 to pi. Now, knowing if a function is even or odd also enables you to simplify your working by just working with one part of the function. Because we shall only work with the function running from 0 up to pi. And that is why we have said then, when we work from 0 to pi, then we multiply it by 2 to show that there was also another part here, but this function and this function would have turned to be the same in terms of the outcome. So therefore we are saying, so since we work with only, since these two are the same, Therefore, we only concentrate in this one function from 0 to L. Right, together. So therefore, I hope you have gotten this. I'll just rub it now so that we can have our calculations. So therefore, we can now calculate our A naught. So our A naught will be given by 2 over pi from 0 to pi. Our ft is this function that runs from 0 to pi. Are we together? Now I can interchange this. This one is positive, this one is negative. So I can just write this one as that. I have not changed anything. Okay, I've just started with the positive, then the negative followed. T is positive, then the negative followed. Then I differentiate that with respect to, I integrate that with respect to t. So therefore, I shall have 2 over pi. What is the rule of integration? Increase the power divided by the new power. So t squared divided by 2 minus. We don't have a constant here. Remember, if we had a t in pi, our t will be to power 0, because anything to power 0 is what? Anything to power 0 is 1. So if I'm saying I increase it by 1, it was to power 0. So if I increase it by 1, it becomes to power 1, which is just pi t. Or in short, we just say introduce the t. From integration, you should know that. Then you have your limits. Then input your limits. So it is 2 over pi. We shall have pi squared. Remember, you're inputting lower limit, subtract the you're inputting the upper limit, then subtract the lower limit. Put this so that you can have. So inside here, inputting the upper limit, you shall have pi squared over 2 minus. If you put pi here, we have pi and pi, so we have pi squared. Then minus, input the lower limit. When you put the lower limit here, t is 0. When you put t here again, when you put a 0 here, it also becomes 0. So it will just be minus 0. The upper limit, subtract the lower limit. Now this value and this value are the same, but this one is just a half of this. So this is just the same as saying a half minus 1. A half minus 1 gives you negative a half. So you shall have 2 over pi. Okay, this part here, remember we're just subtracting 0, so it has no effect, so you concentrate on this one. So a half minus 1 gives you negative a half, so it is negative half that one square. So you just treat pi as just any other constant. Are we together? Yes, this is the same as saying a half x minus x. It just gives you negative a half x. So it is just negative a half over pi squared. But remember, this one is 2, this one is 2, this one is pi. Cancel with 1 pi here. So you remain with your value being negative pi. That is done. Now let's come to an. Our an, again it is 2 over pi from 0 to pi. Our ft is the function, is this function here. Okay, I'll just say it is the function here. Right, then cos n pi t. What is our L? Our L is pi. Then dt. So again, this one gives us 2 over pi from 0 to pi, t minus pi. Now let's see what our cos simplifies to become. The pi and the pi cancelled, sorry. Then you have nt, then dt. So this is your function that you're going to integrate. Now remember, these functions have been multiplied. So we have two functions which have been multiplied. And when you have two functions multiplied together and you are integrating them, you use what we call integration by parts. So we say by parts. What is the formula of integration by parts? The integral of u dv is given by uv minus integral of v du. So this is just the formula. So remember, you let one part of the function to be u, the other one to be dv. Then we get all the missing variables and we just replace them there. So again, we say now let our u will be the first function here. So t minus pi. Then our dv is everything that remains. So it is cos nt d dt. So here differentiate, remember we want du, so in this side you will differentiate, so du dt. So differentiating this one, there's no t here, so differentiating t you get 1, so it is 1. But you want to make du the subject, so du will be given by dt. Just multiply by dt, multiply by dt. So the dt and dt cancels. This side you have dt, or just multiply with that one there. Because this one is 1 over 1, you can multiply by 1 on this side, multiply by dt on this other side. Then, so we have our u, we have our du. We have our dv. What don't we have? We don't have our v. So remember, this one is already a differentiated function. So you want to go back to v. So what do? You integrate cosine of nt dt. Right, together. So our v will be the integral of this particular function. So therefore this one gives you what? So this one will give you, when you integrate cos, you get positive of sine. Are we together? So it will give you sine nt, then divide by the constant. So our constant here is n. So our constant there is n. Now we have everything that we need. We have our u, we have our v, we have our du, we have our dv. So we now replace all these in this particular function. Now take note of this curve, because we shall use it, we shall need it somewhere, or we can just reference it, either the curve or these outcomes here. Because remember, let me just mention it, by letting t equals to 0, we shall get a reference. Our t, when our t is 0, what was our ft? Negative pi. And you can always check that from your graph, that when your t is 0, come down, your value is negative pi. So you can always use the graph or the outcomes here for this part of the function. That is why I'm saying just keep it close, because we shall be needing it. Now so we now calculate our an. Remember, that is what we're calculating. So therefore the integral of u dv, so our u is t minus pi, dv is cos of nt dt, will be given by, what is our u? Our u is this, it is t minus pi. What is our v? Sin nt over n minus, and remember we have a constant, we have a constant 2 over pi, so it should not be forgotten. So you have 2 over pi here, then minus the integral of v du. Our v is this, so sin nt, then over n, then du was dt. You can see everything is here. So we're just substituting our values in this particular formula. So when you integrate that, so integration of this becomes this. That's just what we are saying, 0 to pi. Going further, so this one again, remember we have 2 over pi here, 2 over pi bracket, so t minus pi sin nt over n. Now remember here, you're supposed to integrate now. You're not supposed to leave your answers in terms of integrals. So integrating sine, you get what? Sin nt, you get negative cos. Right, together? Negative cos, and there's another negative here. So this one becomes what? Positive cos nt. But remember, you had an n here. Then drop another n. This one gives you what? N squared. 0 up to pi. So that is important. Integrating sine, you get negative cos. Negative and negative gives you a positive of cos. Then drop another n, because there's already an n here, it becomes n squared. But now we are saying at no point will you have the sine function or the sine series. So this one becomes, you can just cancel it. But all the same, even if you replace your limits, this part here becomes what? Just becomes 0. So therefore we only remain with this part. So we'll have 2 over pi, okay, then cos. Now n. Now since n is a constant, okay, let me just write it first. I'm saying n squared is a constant, you can have it outside, so this one is the same as saying 2 over pi n squared, you can have it outside, okay, so that you just remain with what? Cos n t, then 0 up to pi. Then input your limits. Your upper limit is pi, your lower limit is 0, so you shall have equals to 2 over pi n squared into bracket cosine of n, so it is n pi, okay, then minus cosine of 0, because 0 times n just gives you 0. Now remember this, that cos of n pi is given as -1 raised to power n. Remember this one is just with respect to the values of pi, cos and pi is 180 degrees, remember that. So cos of 180, cos of 360, cos of 720, it goes changing from -1 to 1, -1 and 1, -1 and 1, and so on and so forth. So therefore this part here we shall change it to become -1 to power n, and the cosine of 0 is what? Is 1. You should know that. So we have just write here sake of space, so it is 2 over pi n squared, so this part here becomes n, then -1. So our expansion becomes this. Now at this point we are supposed to remember all through we are getting the value of what? an. Remember all through we are getting the value of an. Alright, together we're getting the value of an. So our an in general will just be given by 2 pi n squared, -1 to power n, then -1. But we have to understand, are our n, does n give us all the values, that is from 1 up to infinity, or is it limited to some specific values? So we say, now we take two conditions. When n is even, when n, remember we're taking the value of n is even. When n is even, what will we have here? What will be our an? Now let me put any value. I want you to really follow here. Let's take any value of even number. So for example, let's take 2. 2 is an even number. -1 squared gives you what? 1. Then 1 minus 1 gives you what? 0. 0 times anything gives us 0. So therefore, when our n is even, your an value will be 0. It doesn't matter which value. If it is 4, if it is 6, if it is 8. Remember, when our value, anytime you power a value by an even power, the value becomes a positive at any point. As long as the power is even, it becomes a positive. So 1, this one will become 1. 1 minus 1, 0. Then we shall have that. Then 2, when n now is odd, when n is odd, what will be our value of an, general value of an? So let's say a value of 1. So -1 raised to power 1 is -1. -1 minus 1, -2. -2 times 2 gives us -4. So we'll have -4 over pi n squared. So therefore we shall have values, a general now representation. This was so general. Now we narrow it down to only know that our n value will only give us values of n or a that are only odd values. So it is -4 pi n squared. So that means, so in this case, this means we can have our values. So allow me to rub that. So we can have our values as a1, which will be, so replace n being 1, so it is -4 over pi 1 squared is 1. We can have a3, which will be -4 over pi then 3 squared. And then you can have a5, -4 over pi 5 squared, and so on and so on and so forth. So it goes on, but only when these values are odd numbers. So 1, 3, 5, 7, 9, and so on and so forth. Therefore, we can now write our Fourier series. So our Fourier series, we say it is given by n0/2 plus summation from n equals to 1 up to infinity of an cosine. Now remember our values, the value of pi and pi cancelled, so this one just remains to be nt for this particular function, because if you can remember, we had a n, the l, pi, and the pi at the top cancelling out. If you can't remember, we had these. So this one and this one cancelled. You can follow keenly. So it just remain with nt. So we will only have those values. And that means, and remember, our value of n, this value of n here is the same value of n here. So when we have 1 here, we have 1 here. When we have 2, this one is 2. When we have 3, this one is 3. Alright? So what was our a0? Our a0 was negative pi, then over 2. Now I can write it first of all generally, then I'll write it in terms of the summation. So our n, so we start with the first one, it is negative 4 over pi, then cos, this one is 1, so t. Then minus 4 over pi, 3 squared, this one will be cos 3t. The value here is the value here. Minus 4 over pi, 5 squared, cos 5t, and so on and so forth. So these are just writing. Then in this form, this is given again by negative pi over 2. What is common here? This one is common, this one is common, this one is common, 4 is common, negative 4 is common. So you can have negative 4 over pi as a constant outside. Then we say summation 1 up to infinity. Are we together? So this one is just a constant. Okay, I've just removed negative 4 over pi because it appears to in every value. Then we can see that our value 1 squared, 3 squared, 5 squared, and so on. So our value is 1 over n squared. The value, the constant that will be there will be n squared. Now I want us to flow together, then cos nt. But this still is not a very well defined, because our n value is supposed to be odd numbers only. So we say it is negative, here, negative pi over 2 minus 4 over pi, summation n equals to 1 up to infinity. Our values are only n minus 1 squared, where this one just represents what? Odd numbers. So we have to be very specific that our n value is not only all values of n. No, it is when your values are odd numbers, and odd numbers are represented by this. So then cos, then again this one becomes 2n minus 1, then you have what? T. And this one, so either in this form or in this form, both of them are the series for ft. So you have ft. So that is the second part. Then the last part, we now solve for the last part. When t, by setting t equals to 0, show that pi squared over 8 is given by this. Now this is simple. Now taking this function here, the one that we have, when our t was 0, what was our ft? When our t was 0, if you can remember, you can check from the drawings that we drew and also from the limits that we had, or even here. When you put 0 here, so when I put 0, when I take my 0 and I put it here, negative pi minus 0, I'll get what? Negative pi. That is how you replace your values on this other side. Right, together. Then negative pi over 2 minus 4 over pi, then summation from n equals to 1 up to infinity, 1 over 2n minus 1 squared, then cos. Now I replace my what? I replace a 0 here also, because remember we are setting values of n to be zeros. Write this correctly. So I'll have negative pi over 2 minus 4 over pi summation n equals to 1 up to infinity 1 over 2n minus 1 squared. Then you have cos. Now I replace my t being 0. T is 0. 0 times the whole of this value becomes 0. But what is the cos of 0? Cos of 0 is 1. So we can see if this value is 1, therefore this value goes. Because the cosine of 0 is 1. So I shall remain with this value. Now what remains is for me to take all these values to the other side so that I can remain with this particular value here. So I can start with this constant, I take it to the other side, so I'll have negative pi plus pi over 2 equals to negative 4 over pi. So summation n equals to 1 up to infinity 1 over 2n minus 1. Then you have squared. This one is 1, this one is a half. Negative 1 minus half gives me negative a half. Are we together? So treat this one as numbers by the end of the day, as variables. Just treat it, because this one is just negative 1, this one is a half of pi. Now I have that. Now I want to remove, okay, let me just write it. So I want to remove negative 4 over pi. So what do? I multiply both sides by pi over negative 4. So I multiply by pi over negative 4 this side, and I multiply by pi over negative 4. Those both sides for me to remove that. Now negative and negative gives me positive. So pi times pi gives me pi what? Pi squared. 2 times 4 gives me 8 equals to summation n equals to 1 up to infinity 1 over 2n minus 1 into bracket squared. Students, and that gives you the last bit. And basically that is how you solve any even function that you have been given. So thank you and see you in the next lesson. Kindly, if you are not subscribed, kindly subscribe and also share. Thank you. See you in the next lesson.